Hello guys, this is Samadhan Kale and welcome to all of you on my YouTube channel. In this video guys, we will discuss the differential calculus. That means how to find the differentiation by using the Python. Before that guys, those guys do not subscribe to my channel, please subscribe it, like and share it. Okay, so that you will get the latest update. So let's start today's video guys. Uh, we are using the Simpy library for finding the differentiation. So first import it. So import this Simpy library, Simpy as sy. I'm giving this short form as sy. Yes, and let's run it. So Simpy is imported. Now same those who do not see the limit video, so please see it. Yes. So if you do not see, I have given the description. I have in the given the link in the description box, so please check it and click on it and see that video. So there also we have used this Simpy library. So in the same way, you have to give the variables x, y and z. Suppose the function in one variable, that is in x variable. Okay, so you have to give this variable x. So you have to define this variable x in this library. So how you can define x is equal to sy dot. Okay, you have to use, this is the symbol. So you have to give the symbol word as a symbol. Yes, symbols, yes is a capital, and you have to give in a symbol, that is x. Suppose there are two or three variables, we will see it later. Okay guys, so this is variable x is defined. Now we have, if you have to find the derivative of the function log of tan of x by 2. Yes, so we will give the function name f is equal to, okay, you have to define log of tan of x by 2. Here I will write the function as what is our function, that is log of this tan of x upon 2. Yes, we have to differentiate this function. So how we can represent? So log in this library is defined sy dot log. Yes, sy dot log of. Now tan is again defined, so you have to use the sy dot tan. Okay, and then x upon 2. So x upon 2. So this is the function that we have defined. Now there is a function for differentiation, that is the diff function. So by using this diff function, we can find the derivative of this function here. So how we can find it? So let's see. I will denote as uh, derivative. Okay, derivative. Okay, underscore x. It means that guys, derivative with respect to x. Okay, that is equal to sy dot differentiation diff. So in this function, we have to give the function and the variable x. Okay, the variable x. So we have to define we have defined this function in variable x. So you have to give here x. If you have defined a function in y variable, you have give here y, and then I will print this derivative x itself. Okay, so this derivative x. So I have to print it. Let's print it and run it, guys, to see what will happen. So you will get, this is the differentiation, that is a tan x by 2 square upon 2 plus 1 upon 2, and this is upon tan x by 2. Yes, so this is the derivative of the function. Okay, and if you cut the this print function and run it, so in more the visual way. Yes, so if you cut the print statement, you will look like this. Yes, like a mathematics. So this is the first derivative. Now guys, again we find the second function. Suppose we have the function as, this is my function, log of sec of e raised to x square. Yes, e raised to power x square. Yes, x square. So this is my function, e raised to power x square. So I will write this as x square in bracket. Yes, so e raised to power x square is my function. Now here is again one variable. Yes. So you have already defined the x variable, so no need to give the x. So only define function f. So f is equal to, you have to give sy dot log of, then again sec function is defined in library simply, so sy dot sec. Yes, again give the bracket, then exponential function, so it is defined as sy dot exp. Yes, exp exponential. Yes, and that is x and its square, so double star 2. So before that, guys, all of you have learned this exponential, sec function and log function in math module also. Okay, so those who do not view that video, I will give the math modules video link in description box. Please check it and see it also. Yes, so this is my function. Yeah, now I have to differentiate this function, so I will write it as derivative with respect to x is equal to this sy dot differentiation of the function f with respect to x. So you have to give the function and its variable, and then print this derivative x. Let's see what will happen. See, this is the derivative 2x into e raised to power x square into tan e raised to power x square is the derivative of the function. If you don't believe on this, so take your pen and notebook and solve it. You will get the same answer that Python has given. Yes, so this is our second function. Now guys, I have taken some another function in three variables. Yes, so this is my function x into cos z, x into cos of z, and then plus this is x square into y cube. Yes, into y cube and into e raised to power z. Yes, into e raised to power z. So this is my function. So how I can define it? Now here are three variables. So first I have to define these three variables. So x is a variable, comma, y is a variable, and z is a variable, and that is equal to. Now these variables are defined in the simple library, so you have used sy dot. Now there is a symbols function. It is a plural, na? These are the plurals. X, Y, Z are the plural. So you have to use the symbols function, symbols. But in symbols, S is a small. First S is a small, this S is small, and in plural, symbol S is capital. So remember this one. Now symbols. Which symbols you have to give in a string? Okay, X, after X give the space, Y after Y give the space, and then Z. Okay, so these are the three variables that we have defined in the library. Now you have to define the function f. So f is function. So what is function, guys? Firstly x. Okay, so I write x, okay, into, so into, then what you have to write? You have to write in bracket. Yes, uh, cos of z. So this cos is defined in this library. So sy dot cos of what? Z. So this is a z. Yes, then what is the next? That is plus. Okay, so give the plus sign here, and then x square. So this is x. Again write this in another bracket. So x double star 2. Okay, so this is my function x square into, so this is into, then what is into y cube. So y, so again give the bracket. Yes, y double star 3, that is y cube. Yes, again it is multiplied by, so give the star, and it is multiplied by e raised to power z. Okay, that is exponential of z. So how you can write this function? So sy dot, this exponential is defined in simple library, so exp exponential of this variable z. So in this way I have defined the function here. Now you have to write derivative of x, okay, is equal to this sy dot differentiation, okay, of the function f with respect to variable x. Suppose you have to find the function's derivative with respect to x, you can find it. and then give this derivative. Let's see. So this is the derivative of the given function with respect to x. Yes. Suppose you want to find the derivative of this function with respect to y. Yes. So how you can write? So derivative of function f with respect to y is equal to, you have to use sy dot differentiation function. Yes. Then function f, and let's change the variable. Instead of x, you have to give the y, and lastly this print the derivative with respect to x. So you will get the derivative of the function f with respect to y. Yes, with respect to y. Now suppose you want to find the derivative of this function f with respect to z. So with respect to z, yes, it is y here, then it will be printed. Yes. So this is the with respect to y. So with respect to z is equal to, you have to give sy dot differentiation of function f with respect to z. So give the variable, change the variable z, and right here also, oh, right here also instead of x, z. Yes, and let's run it. So you will get the derivative of the function with respect to x, y, and z. Suppose guys, if you have to find the derivative of these functions, that is the second derivative, derivative of x, okay, derivative of this function f with respect to x and its second derivative. You have to find the second derivative with respect to x. So how you can find? I will copy the same code here, yes, and paste it below. Now you have to find the derivative of f with respect to x, and which derivative, what is the order of derivative? That is 2. Second order derivative that you have to find. So comma, you have to write the 2, and let's run it. So you will get 6xy cubed into e raised to power z. That is the second order derivative of the function f with respect to x. Suppose you have to find the third order derivative, you will write it as 3. Okay. Suppose you have to find the fourth order, you will write 4, and it is a fourth order, 0 is a 0. Sorry, fourth order derivative is 0, and all order after when this order is greater than 4 or equal to 4, these all derivatives are 0. Yes. So this is the thing. Suppose you have to find derivative of function f's derivative with respect to y, and that is of second order. Yes, that is of second order. You will use the same function, and comma, you have to give the 2. So you will get the second order derivative of function y, sorry, of function f with respect to y. Okay. If you want the third order derivative, you can give the 3. Yes. If you want the fourth order derivative, yes, you can give the 4, and it will be 0. Yes. And suppose you want the derivative of the function f with respect to z, and that is the second order derivative. Okay. So give here comma and 2 or 3, anything. Yes. So this is the third order. Suppose you give the fourth order derivative. So this is the fourth order derivative again. Suppose you give the fifth order derivative. So this is the fifth order derivative. Yes. So these are the orders of the derivatives, and you can find any order derivative with respect to x, y, and z. Okay. So this is the thing. I hope guys all of you understood the derivative concept. Now I will take another function also. Yes. Suppose f is equal to x square into y. Yes. Let's take this x square, and it is multiplied by y. Okay. X square into y. Already we have defined all these variables x, y, and z. Okay. So plus there is a sine function. So sy dot sine of x. Yes. So sine of x I will write, then plus cos of x. So again sy dot cos of x. Yes. So you have to write this, and suppose you want to find the derivative of this function f with respect to y. Okay, with respect to y. So you can find it, the derivative with respect to y, and it is here. Let's see, it is x square. Suppose you want to find the derivative of this function f with respect to x, so it is the with respect to x. And if you want to find with respect to z, so it will be 0. Yes, because the variable z is not included. Yes, suppose you want to find with respect to x and it's a fifth order derivative, so it will be this. So this is the thing. By using this, we can find any function's derivative using the Python. Yes, I hope guys all of you understood the derivative concept by using Python. So thank you for watching the video.